Yo, 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 yo. Yo, yo, yo. Yo. Hey, guys. So, 1.3, solving equations with the variable on both sides. So, some of this will definitely look familiar. Actually, most of this, or all of this, should really look familiar from last year. So, really, this is almost all review, which is nice. But if you don't remember, that's why we're doing it. So, we're going to still use inverse operations today. We're still going to be solving equations, but now the variable will be on both sides, which could create some unique scenarios, such as the identity, which is infinitely many solutions. We'll get to that when we get there. So, first, we're going to solve for x. So now if we notice, I have an equal sign here, but now I have a variable on both sides of the equal sign. So our goal is to get the variable to the same side, and then we will solve from there. So what we're going to do is we are going to first, let's simplify the left and simplify the right. Sometimes it's really easy just to simplify the left side by combining like terms, simplify the right side by doing distributive property, combining like terms, and then we'll look at moving some stuff around. So if I look at the left side, I can combine 3x and 4x to make 7x. The minus 10 stays there. There's nothing else I can do on this left side. To simplify the right side, let's do distributive property first. So that becomes negative 2x. Negative 2 times negative 4 is positive 8. And then I bring down this positive 9. Now I'm also going to combine like terms again. So this is going to leave a negative 2x plus 17. And the left side hasn't changed. So what I did is I simplified just the left side of the equal sign by combining like terms. I'm not doing inverse operations because I'm working on one side of the equal sign. Same thing on the right side. And here's where I'm at. So now I got 7x minus 10 equals negative 2x plus 17. This is where we want to bring the variable to the same side of the equal sign. So what I can do is I can move all of 7x over to the right side, or I can move all of negative 2x over to the left side. But we don't do it by combining like terms. This is where we do it by doing the opposite. Because I want to move something over from one side of the equal sign to the other, I have to do the inverse. So I'm going to move over the negative 2x. Because the opposite of minus 2x, when I want to make this 0, is positive. All of 2x though. So I'm adding 2x. Because negative 2x plus 2x is 0. And then I have to do it on the left-hand side. So that's going to give me 9x, because I added 2x to both sides, minus 10 equals 17. And then now I have a simple equation that I can solve, and I get x equals 3. So there's only one solution. So x equals 3 is the only possible solution for this equation that makes it true. If I plugged in 3, it would make the left side and the right side equal to each other. So x is the only solution, so there's one solution. X equals 3. Okay. Any other value I try to plug in for x will not work. So let's look at another example. So here I have n on the left side, I have n on the right side. Let's simplify the left and the right. Well, it looks like the right side's already simplified. So now let's simplify the left side. 1/2 times n is 1/2 n. I could also multiply by 2 on everything if I wanted to get rid of this. So you have a few options. If you wanted to get rid of the fraction, you could. And you know what? Let's do that. Why not? So I'm going to multiply by 2, but I have to multiply every term that's not inside the parentheses by 2. And that still applies here, and I can do it on both sides of the equal sign. So that's going to make those go away. I'm left with 1 up here, so I don't really have anything to distribute, so now my parentheses are also gone. And that's minus 14. Negative 2 times positive 2 is negative 4n plus 12. Cool. So now I'm going to simplify the left side. The right side's already simplified. So I'm going to simplify the left side to get n minus, I combine negative 4 and negative 14 to get negative 18 equals negative 4n plus 12. I'm going to add 4n to both sides because this is where I got to change it and move it over to one side. And I'm going to do that by adding 4n. I like to get rid of, if there's a negative, I think adding is a lot easier. And also, I like to look at it real quick and figure out what's going to keep my variable positive. Just so I don't have less negatives to deal with. It doesn't matter which way I decide to move it. Doesn't really make a difference. So 5n minus 18 equals 12. Add 18 to both sides. 5n equals 30, and I get n equals 6. So again, we still only have one solution. So this n equals 6 is the only solution that would make, if I plug in n equals 6, it's the only thing that would make the left side and the right side equal to each other. Okay. Start off this one on your own, see how you do. So pause it, try it, see what happens. So I'm going to simplify the left and simplify the right. Left sides are all the way simplified, 4x plus 6. So I got to simplify the right side by doing some distributive property. 2 times 2 is 4x, 2 times 3 is 6. So I get 4x plus 6 equals 4x plus 6. Perfect. So 4x plus 6 equals 4x plus 6. If I look at the left side and the right side are the exact same thing. So if I were to try to move my variable over, because the left side is 4x plus 6, the right side is also 4x plus 6. They're the identical thing. Or they're both identical. So if I were to try to subtract 4x from one side, and I did on both sides, my variables go away. And I'm left with 6 equals 6. This is known as the identity, or as an identity. This is infinite solutions. The reason why, because the left side and the right side are completely the exact same thing. They're identical. And I have the variable. That means I can plug in any number in the world. Any number. And it would actually make the left side and the right side equal to each other. If I plugged in 1, 4 times 1 is 4, plus 6 is 10. 4 times 1 is 4, plus 6 is 10. Because the left side and the right side are equal to each other, there's infinitely many solutions to this. So the solution is infinitely many solutions. Okay, I want you to try both of these on your own. So pause it and then just see how you do. And then what I will do is I will unpause it, and then instead of walking you through it, I will actually just have the solution for you. So go ahead and pause it, try it, see how it goes. So here you go. These are the solutions. Now, a couple things I want to point out. First is that for number 1, you get y equals 1. When you distribute, this one was pretty self-explanatory. I added 3y to both sides just because that was a negative and it kept my variable positive. For the second one, the biggest thing to point out was that you do have to distribute this negative to make both negative 5a and negative 6. And then again, I chose to add the 5a because I wanted to keep my variable positive, so now I move the variable over to the right. Doesn't change anything. I still get a equals negative 2. So last two problems, pause it, try it, see how it goes, and then I'll show you the solutions. Okay, here you go. So this first one, I chose to move my decimal over. Again, everything we learned beforehand still applies. So I want to multiply everything by 10, so I move my decimal over once. Just remember that if you do that with the whole number, you have to add a 0. So the equation really became 68 minus 42b equals 56b minus 30. There's one solution for this, and that's just 1. Second one, I chose to multiply everything by 3. They all had a common denominator, so I made it really, really simple. I actually probably didn't even need to multiply by 3, but I'm sure a lot of you did. And so just to get rid of those fractions, so I ended up with 1 plus 2m equals 2m minus 2. When I subtract 2m from both sides, my variables cancel out. But now I'm left with 1 equals negative 2. The left side and the right side are not identical. They are not the same. When this happens, that means there's actually no solution to the equation. So when everything cancels, but the left side and the right side are not equal to each other, but my variable goes away, that means there's no solution to the equation. There's not any possible way to solve this particular equation. There's no number that would make the left side and the right side both true. So whenever we're solving, we always have the possibility of one solution where we just have one value that makes it work. We have the possibility of no solution, or we could always have infinitely many solutions. And that's all I got for you guys. I hope this helped solve this independent practice, see how you do. If you guys have any questions, please do not hesitate to ask. And that's it. Thanks for watching, and see you guys later. Gordias out.